Okay, this is part two. So how tall do you need to be to play in the NBA? Well, it depends on what position you play. And we're going to look at the average height of the shooting guards. So really quick, this is 123 of them. Here's the mean and the standard deviation. And as we can see it in the shape, we got a skewed left graph. Okay, so thinking about our lesson, we're going to say skewed left. And our mean, which is our mu, is 76.33. Our standard deviation, which is our sigma, is 1.673. And again, we got that from the other little graph. This is what we call the population distribution. Okay, so we're talking about the population of shooting guards that we have. Okay, so we're going to take a random sample of two shooting guards and find the mean of the sample. We're going to do that 3 times. So if we did that, we would get something means like this. So 77.5, 75, and then 77. Okay. Now, take a random sample of 10 shooting guards and find the mean of the sample. Okay, so sample mean, let's say we did it again, 76.1, 76.6, and 75.9. Okay, this is what we call the sampling distribution. So on 2 and 3, those are sampling distributions with n is 2 and n is 10. Okay, add your sample means to the dot plots on the board and sketch them below and describe each distribution. So on the first one, this is all of the ones with n equals 2. So let's say that we ran this and then we graphed it. We would have something like this. So this would be skewed left. And if we added up all these dots and divided by how many dots there were, we and our mean would get us 76.33, which is what we got at the beginning. And our standard deviation is found by taking our sigma and dividing by the square root of n. So n was 2, and that's going to give us 1.18. If we did the same thing, but when n equals 10, we would get a graph like this. 1, 1, 2, 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 5. Sorry, that's a little not straight. And 2, 3, 1, 2, 1, 1, and 1. Okay, this one is going to be closer to approximately normal. Okay, and the mean is still the same, 76.3 repeating. But our sigma is going to be a little bit different. And that's because our square root of 5, or I'm sorry, square root of 10 is going to make that 0.52. So we went from 1.18 to 0.52. Notice how our standard deviation is closer to it. So to be safe, we would use n is greater than 30. That'll really kind of help us out and make sure that we're getting closer and closer to the actual true standard deviation and mean, right? This is what we call the central limit theorem. Okay, we'll talk more about that in just a second. Now, use a normal distribution to find the probability of taking a random sample of 30 shooting guards with replacement and getting a sample mean more than 77 inches. So we're going to get C equals, we're trying to find 77. Our mean is 76.3. And our standard deviation is going to be 0.305. Okay, remember the way we get 0.305 is we took sigma and then divided it by the square root of n equals 30. The reason why we would want 30 is we would want it to be greater than or large enough in order to give us the best approximation for our standard deviation. Okay. So, and that's what the central limit theorem is. N is greater than 30. Okay. Greater than or equal to. So when we do that, sigma is going to be 0.305. When we plug all of that in, that's going to give us 2.19. When we look into our table, that means that our area is going to be 0.0143. Sampling distribution chart is going to look like this. 76.3 repeating. And then we want greater than 77. All right. So flipping over to the back, we talked about two things. Talked about the central limit theorem. Okay, so the central limit theorem. That's the sampling distribution of X bar is approximately normal when sample size is large enough. Okay, then we talked about normal probabilities. I still talked about Z being X minus mu divided by sigma divided by the square root of N. Okay, when you do your little normal distribution, don't forget to have N is your mu and your standard deviation. Okay, you're gonna try A, B, and C, and we're gonna check them tomorrow in class. Okay, so please make sure that you do A, B, and C tomorrow. All right.